Hello friends. In today's lesson, we are going to talk about left view of a given binary tree. So what is a left view? So left view of a binary tree is the set of nodes which are being visible when you look at the tree from the left hand side. So given this tree, the left view of this tree would be, so if we are looking it from the left hand side, so 8 would be visible. Similarly, 5 would be visible. Now 2 should be visible and 3 should be visible. So the left view of this tree would be 8, 5, 2 and 3. So how we can achieve this programmatically? The prerequisite for this operation to happen is you need to understand the label order traversal. We have explained it in detail in our previous lessons. So if you have not watched that video, I'll strongly encourage you to go back and have a look. Okay, so we can use the label order traversal on this problem to print the left view of this binary tree. So let's look at what will be the label order traversal. Label order traversal traverse it through all the labels. So this is label 1, this is label 2, this is label 3, and this is label 4. Okay, so if you look carefully now on all the labels, the very first element would be our left view. So for the first label, we have 8. 8 is our first element. For the second label, we have 5. For third label, we have 2. For fourth label, we have 3. Let's look at another example and see what will be the left view of that binary tree. Let's say I have a tree, something like, let's say 1, then let's say 2 and 3 over here. Okay, and 4, then let's say 5, okay, then let's say 8. Okay, so if we want to print the left view of this binary tree, so what will be the answer? The answer should be 1, 2, 4 and 8. So the answer should be 1, 2, 4 and 8. So we can go ahead with the same approach what we have discussed. This is label 1, this is label 2, this is label 3 and this is label 4. For each label, we are taking the first element. Okay, that makes our answer 1, 2, 4, 8. All right, now that we understood the problem statement, now let's see how we can achieve it programmatically. Okay, so programmatically we'll do the same operation as we do in label order traversal using a queue, and instead of printing all the elements, we will only print the very first element on a particular label. So what we can do, so we'll take a queue and inside this queue we are gonna push the first element. Now let's push the very first element or the root element 8. So for the label 1, 8 is the first element, so we are gonna print this as well. So we will print 8. Now we'll take out 8. So once we are taking out 8, we need to insert its left child and the right child as well. So we will insert 5 and 4. Now we'll take out 5. So 5 is the first element in label 2. So we are also gonna print 5. Now when we are taking out 5, we should push its left child and right child. So for 5, its left child and right child both are null, so nothing to push. Now the next element in the queue is 4, so we'll take out 4. Now when we are taking out 4, we should push its left child and right child. So left child is 2, right child is 1. Now we'll take out 2. So when we are taking out 2, 2 is the first element in label 3. So we are gonna print 2. Now we should push its left child and right child. So for 2, the left child is 3 and it does not have any right child. So we are not gonna push anything. Now let's take out 1. So for 1, if we are taking it out, we are gonna push its left child and right child. So for 1, right child is null, left child is 9. So we are gonna push 9. So next we are gonna take out 3. For 3, there is nothing to push. Both are null. Okay. But 3 is the first element in label 4. So we are gonna print 3 as well. And then similarly, we will take out 9 and we're gonna push its left child and right child, but both are null, so nothing to push. So now our queue has become empty. So whatever result we got, so that is our left view of binary tree. All right, so let's go to Visual Studio and implement this programmatically. If you are following my lesson, so you'd have already known about the solution where we have implemented a tree traversal and few of the tree operations as well, like get height and is binary search tree. So now we are going to implement the left view of the binary tree. So I'm going to just say, let's say public static. So it's going to be void. So left view of tree. And we are going to receive, let's say a node. And this is the root node. So let's say I'll say if root is equal to null, then we are not gonna do anything. We'll simply return. In other case, we want to use a queue. So I'll use a list for the queue. So let's say a list of nodes. I'll call this as queue equal to new list of node. Okay. So into the queue, we'll push the root node queue dot. So we can add the value queue dot add. So we'll pass the root element to it. Now what we want to do, now we are gonna take it out, and for each label we want to print the very first element. So I'll run a loop. I'll say as long as queue is not empty, queue dot count is greater than 0. So what I want to do, we have to print the element in a label by label order. Like for the first label we have to print 8. For the second label we need to print 5 and 4, and we need to grab the first element on the label. So what we can do is, so let's say I'll grab the queue count. The count is equal to, let's say whatever element there in the queue, queue dot count. Okay, so next I'll run a loop. As long as the count value is greater than 0, so what we are gonna do is we will do a count minus minus. So what we are doing on this statement, so for each label, let's say on the first label we have a single element into the queue. For the second label we'll have 2 elements. So we are going in the backward and we are checking as long as there is no element on this label. Till now we are doing the operation. So what we want to do, we want to now dequeue the element from the queue. So let's grab the element to be dequeued. So I'll say variable element equal to queue dot element at 0. Okay, now we need to print if it is the very first element for that label, then we are gonna print that element. So I'll create a, let's say, counter object. So this counter is equal to 0. So in case the counter is if the counter is equal to 0, then this is the first time we are printing for this label. So we are gonna print the element data. So console dot write line, we're gonna print element dot data. Okay. So once we print this, let's dequeue it. I'll say queue dot remove the element, remove art, the beginning, the very first element I want to remove. Now the next thing, so once we are removing the element, what we want to do, we want to push its left child and right child. So we can do something like if element dot right child is not equal to null. So in that case, we can push q dot add element dot right child, element dot right child, and in case the left child is not null, then we'll push the left child. Okay, so element dot left child. All right, so now we have pushed the right child and left child, and now we need to increase this counter as well. So I'll just increase the counter over here, counter plus plus. Okay, so that's all the code that we need for displaying the left view of the binary tree. Now let's go back to the driver code or the main method where the execution starts and verify the implementation what we did is correct or not. So I'll go to program.cs. So in program.cs, I have already created the tree what we have been discussing so far. This tree, I have already created it over here. Now what we can do is we can simply call our method tree operation dot left view of the tree. So this left view of the tree takes the root node. Root node is left view tree. So I'll pass the left view tree and we can add simply a console statement. So I'll say console dot write line left view of binary tree. Okay. All right. So now let's run this code and see if the output matches our expected output or not. So what is it we are expecting? We are expecting our output should display 8523. So let me run this. Okay, the execution completes. Okay, now if you look at, we got back left view of binary tree is 8413. So let's see what went wrong on this program. So let's stop the execution. Let's go back to tree operation. Okay, so the problem is in line number 78, 78, 79, and 80. So if you look at, so instead of adding the left child first, we are adding the right child. So instead of pushing the left child as the first element, we are pushing the right child as the first element. That is where the problem is. So let's fix this. So I'll just take it to the top. Okay, now let's run our code. Okay, the execution finished. Now if I look at the output, what we have received is 8523. Let's match to our expected output. The expected output is 8523. All right, guys, so this is the left view of binary tree. The code I will be publishing to GitHub and you can find the link in the description. Please subscribe to support us and thanks for watching.